In this video we're going to use calculus to sketch this graph. So we have no idea what this graph looks like. So the normal routine is to see where it jumps to when x is 0, 1 and -1 because they're easy points. So let's see where it jumps to when x is 0. When x is 0, put 0 into here. So you've got one block times another block. So put 0 into the x and e to the power 0 is 1. So 0 times 1 is 0. So it actually jumps to here when x is 0. When x is 1, so that would be 1, and then e to the power 1 is just e. So so it would jump to 2.7 something. So let's just imagine this is 1, 2.7, somewhere around here. And let's see where it jumps to when x is -1. So when x is -1, so when x is -1, so that would be -1, and then e to the power of -1. We don't understand what it means to have a power of a negative, so we jump to 1 over e to the power of 1. And then this -1 gets multiplied to the top, so that would then be a negative. So we've got -1 over e. This e here is 2.7 something. Let's just imagine it's -1/3. Let's just imagine this is the number 3. So -1/3, it would be somewhere around here. So we know our graph passes through here, here and here. So far we know the graph passes through these 3 points, 1, 2, 3. So now we'll find out what happens when x is very, very big. Let's say 1000. Well, me asking you what happens when x is very, very big is the same as me asking you this. What is the limit of the function that we're talking about as x heads towards infinity, meaning as x heads towards all the way to the right, meaning when x gets very, very big, let's say 1 million. So to investigate, let's just imagine 1000 for the time being. Where will the graph jump to when x is 1000? So let's put 1000 into here, and let's put 1000 into here, e to the power of 1000. So you can see that this thing here is going to be very, very, very big, and this thing here is going to be very, very, very big. So when you have one big number times another big number, it would be very, very, very big. So we know that as x heads towards infinity, this thing here, the limit, will head towards infinity. So what that means is when x is very, very big, it will jump to very, very big. It will jump to all the way up here, not to scale. So we have a hunch that the graph will look something like this. We have a hunch that it looks something like this, but we don't know for sure. We just know that it's going to be very, very big. Okay, so now let's investigate what happens when x is negative, as x heads towards -infinity. So imagine as x heads towards negative, very, very big. So we've got one block times another block. So let's just imagine putting -1000 in here. So you've got -1000 as one block, and then you've got e to the power of -1000. We don't understand what it means to have a power of a negative, so jump to 1 over e to the power of 1000. And then so that's one block, and this block here, you've got a block of -1000. Let's just multiply this to the top, so that will then give us -1000 over e to the power of +1000. So the question is, what will this thing become when x is very, very negative big? So so hang on, so we've got this thing here. Let me just take the negative out of the bubble. So our number, we know, is going to be a negative number, because this thing here would never be negative, because e to the power of, well, the e graph looks like this. 1000's up here. This thing here would never be negative. It would never be negative. So we know that this bubble alone here will always be positive, and you've got a negative out here. So the answer would be in the negative realm. It would never be up here somewhere. It must be in the negative realm somewhere down here. So now let's investigate what happens to this number here. Which number would be bigger, 1000 or e to the power of 1000? Well, I know the number e is 2.7 something. Let's just imagine it's the number 3. Let's round off to 3. I know it should be 2.7 something, but let's just imagine it's the number 3 to the power of 1000. So which number would be bigger, this number or this number? Well, if you think about it, 3 to the power of 1000 means 3 times 3 times 3 times 3 times 3 times 3, 1000 times. Alright, if it's not 1000, let's imagine it's 1 million. 1 million times. So times it by, and then this number here is fixed at 1000, at 1000. So you know that as x gets to 1 million, 3 times by itself, 1 million times, 1 million times, you know that the denominator will be so much bigger than the numerator. So you know that this thing here would be very, very, very small. But don't forget you've got a negative here. So this thing here will be very, very, very small. So you know the graph will look something like this. Very, very, very negative small. So it's going to look like this. Okay, so the graph, as x heads towards infinity, it will become very, very big. As x heads towards negative infinity, it will head towards 0. It would just get very, very, very small. But earlier we noticed that it's on the negative side because we have negative very, very small. So it's approaching 0 from the underside, if that makes sense. It's heading towards 0, but from underneath the graph. It would be in the negative realm basically, as opposed to above the graph. So we know the graph looks like this and something like this. So we suspect it will look something like this. But don't forget, it could wobble somewhere in between. It could wobble somewhere in between. But so far, all that we know is that it passes through these 3 points, 1, 2, 3, and it's going to be very, very big and very, very negative small. So far, we know the graph looks like this. So far, we know the graph looks like this. It passes through here, here, 1, 2, 3. So now let's investigate. Don't forget, it could do something like this. And then wobbles. It could do something like this. Let's find out, looking at this, let's find out where it crosses the x-axis. Okay, so put 0 into the y to investigate. So that would be 0 equals x e to the power of x. Remember, we're trying to find out where it crosses the x-axis, because it could cross the x-axis here, 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 and maybe here and here. So find out where it crosses the x-axis. So put 0 into the y and then try and solve this. Well, here you've got 0 equals x e to the power of x. You've got one block times another block. This block here will never be 0 because e to the power of x looks like this. It will never be 0. It will always be a positive. So if you want this to be 0, then the only place that the whole thing can be 0 is when x is 0. So it can't be over here, because let's just say this is negative 7. Negative 7 times a positive number would never be 0. So the only place that will cross the x-axis is at x equals 0. So we know that it will never do this, because here, well, the only place that it crosses the x-axis is at 0 here. So we know it must pass through here. And let's look at the gradient to detect if it wobbles or not. Because if it wobbles, this will be 0, this will be 0, and so on. So let's differentiate this. So when you differentiate this, you've got to use the product rule. So differentiate the first, which would be 1, leave the second alone, and then plus, leave the first alone, and differentiate the second. So that's us using the product rule. So when you differentiate this, it will give you this. So when will the gradient be 0? Let's put 0 into the dy by dx. So we're trying to find out when the gradient will be 0. So that would be 0 equals ex plus xex. So let's this is in common, e to the power of x is in common, factor out e to the power of x. That would be this. So when will the gradient be 0? Because the graph could look something like this. And then you've got lots of zeros around here. But as it turns out, that the only time that dy by dx equals 0 is when x is -1. This is the only time when it's 0, because here you've got one bubble times another bubble. This thing here will never be a 0, because e to the power of x will never be 0, and it will always be positive. This thing here, the only place that dy by dx equals 0 is when x is -1. So this here, we know the gradient here is 0, it's flat right here. And it won't do this, because if it does do this, then this dy by dx will be 0 here, 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 and so on. But we've just established that it will only be 0. The gradient will only be 0 right here. So we know that the graph would do this. Well, hang on. Let's look at this thing here. Hang on. Ex. So earlier we had this 1 plus x here. So if you look at this, from here, or from -1, beyond -1, all the way to the right, this thing here will never be negative. It's always positive. It's always climbing. So you know the gradient is always climbing. So always do this. And then from here, from -1 down to here, so let's just look at -3 here. You see, if I put -3 in here, then 1 plus -3, it will be a negative number, e to the power of x. So you know that this thing here will be negative. My point here is that less than -1, this thing here will be negative, meaning that the gradient dy by dx will be negative, meaning that it's always going downhill, downhill, downhill. So it's always doing this, going downhill. So beyond here, the gradient would be negative, meaning it's always going downhill. And from -1 onwards, it will always be going uphill, uphill, uphill. So your graph will look something like this. Okay, so if you get a graph plot and plot this, so imagine you being here. Hang on. Imagine this is you walking along here. Hang on. Imagine this is you walking along here. So this is you here, walking along here. So you're walking downhill, downhill, because we know that beyond negative. Well, we know that this is -1 here. We know that in this region you're always going downhill. So as you're walking along here, you're always going downhill, 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 downhill. And then by the time you get to here, you're always going uphill, 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 and so on. So your graph looks like this. Okay.